Riley is toot on November 21st. So today is Monday, November 4th, 2019. We are talking about triangular related rates. This is the last related rate problem that we have, last lesson that we have. Again, so 11/4/2019. Our objective. Go for it, someone.
Solve related rate problems dealing with the lengths of the right triangle.
Yeah, so you know how I told you guys you need to remember like 3 things? So you need to know the formula for circumference, the formula for area of a circle, and finally Pythagorean theorem. Once you have those 3 things memorized, you're done for this unit. That's all the memorization you have. And of course, you have word problems, so it's a lot harder. But let's talk about the Pythagorean theorem. First of all, give me the Pythagorean theorem.
A squared plus B squared equals C squared.
Good. All right, so if I have a squared plus b squared is equal to c squared, now we're going to take the derivative with respect to time, some variable that's not up there. Go. 2a prime, good.
Plus 2b prime.
Good, equals,
2c c prime.
there it is, 2c prime. And what could we divide both sides of this equation by to simplify it a little bit?
2.
2. So if I divide by 2, I have a prime plus b prime is equal to c prime. And that's the trick. Like, it saves you a little bit of work. But that's what you're going to be using over and over again. All right, so who wants to read example 1?
The top of a 10-foot ladder is sliding down a vertical wall at a constant rate of 12 feet per minute. When the top of the ladder is 6 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall?
All right, so especially for triangular related rates, always draw a picture. Maybe not with spherical related rates because it's kind of hard to draw spheres and doesn't really help you because you're just going off of your formulas, but these ones are really important to draw pictures. So say pictures on the side here, exclamation point, whatever. Let's go ahead and draw the picture right now though. So I'm going to draw the picture out here to the left. Don't make it too big.
Make it extra big, alright.
All right. And instead of saying what are we looking for, we'll just label the diagram with what we're looking for and what we're given. All right, so let's assume that this diagonal thing is a ladder. If you want to try to make it a picture, you can say, oh, there's a ladder and it has the rungs of the ladder. You can do whatever you want for your picture. As long as it's a right triangle, then you're good. So we have the left leg, the bottom leg, the hypotenuse. Tell me what I can label on this thing. We can arbitrarily say A or B or X and Y. I don't care what variable you do, just try to be consistent. So anyone, what do we got? Hypotenuse is 10. We're going to call it H or C?
C.
All right, C is equal to 10.
And C prime is 12.
C prime? Or what?
Yeah, C prime is 12.
C prime is not 12.
Oh, is it negative 12?
So how fast is the ladder changing size? Does the ladder turn into a shorter ladder? Does the ladder get elongated?
What if this side is...
Generally speaking, whenever you're having a falling ladder problem, the ladder's not changing size. Like, it's just going to be the same ladder. It's a really unfancy ladder that doesn't slide up and down. So what is C prime? How fast is the ladder size changing?
0.
It's not changing. C prime is going to be 0. And that's almost always going to be the case with anything static falling down, is the size of that static object is not changing unless you're in some weird dimension that we don't know about. All right, so what else do we know?
B is equal to 6, which is the vertical.
So we're going to say B is equal to 6 over here. All right.
But it would be B prime.
B prime is the rate in which this distance right here is decreasing. So B prime is what? Yeah, so B prime is going to be, ooh, I like how you said negative 12. B prime is equal to negative 12 because it's falling down. Okay, what else do we have?
I have a question.
That's good too. Yeah, what do you got?
How do you get negative 12?
Someone explain.
It's in the problem. Right there. Yeah, it's like...
So it's sliding down, so down means negative, 12 feet per minute. So we could either label this as 12, this is 12, but this is the down direction. This would be the right and left direction. So we chose the down direction on
And
the
it's negative 12 because it's going down, right?
going down. You could have just said positive 12, and then you have to reorient yourself, and that's kind of the same thing with physics. Is you could think of this as positive gravity or negative gravity, and maybe your equation already deals with the fact that it's negative. But yeah, I like the idea of negative 12. That makes sense to me. Like down is negative. Do we have any other information? We do have the fact that it's a right triangle. Doesn't really say that in the problem, but you should assume that it's a right triangle because it's this type of problem. So if it's a right triangle, then we can figure out what A is.
Do ladders ever really fall like this? I don't know.
They do. It would be fun to actually go do a recording and then make our own problem.
Sideways, Claire. It didn't fall this.
It was still falling.
Can we figure out A?
Yes.
Can you guys do that in your head?
Square root of 130.
Is it 4? No, it's 8.
Square root of 164.
Oh, right, 64.
It's gotta be.
Which
It's
is
136, sorry.
Right? Maybe? No? 6 times 6 is.
36.
Oh, so yeah, it's 100 minus 36, which is 64, yeah. And then square root of 64.
There
8.
we go.
So A is 8. If you don't know what we were doing there out loud, we were doing 6 squared plus A squared is equal to 10 squared. And we said, okay, 6 squared is 36 plus A squared is equal to 100. We subtracted 36 from both sides. We said A squared is equal to 64. And then we square rooted and we said A is equal to plus or minus 8. Doesn't make sense to be a negative distance. So we'll just say positive 8. So that's a good first step. Now we have all the lengths of the triangle, which is useful because if we come up here to our equation after taking the derivative and doing some simplification, we need 6 variables. Oh my gosh, lots of plugging in. So do we have A?
Yes.
Do we have A prime?
Yes.
No, but that's what we're searching for.
Oh.
So if I come back down here, A prime is our box or our question mark. What is the rate of change of the distance between the bottom of the ladder and the wall? The bottom of the ladder and the wall. What is the rate of change that is changing? Well, that's definitely A prime. Okay, so A prime is the thing we're trying to find. So we have A. We need to find A prime. Do we have B?
Yes.
Good. Do we have B prime?
Yes.
Do we have C? Do we have C prime?
Yes.
We literally have everything but A prime. So we can just plug it in and solve, right?
Yes.
All right, so come down and start plugging into that equation. So A is 8, A prime is still A prime, plus B prime, so it's going to be 6 times negative 12, is equal to C times C prime, 10 times 0. Yeah, the hardest part about this problem is knowing that C prime should be 0, and knowing that you need to use normal Pythagorean theorem without taking the derivative in order to solve for A. So I'll put like little stars or asterisks next to A and C prime. Those two were a little bit tricky, but you should know how to get there. Those are the 2 new things that we added to the problem before we can even solve. All right, so I need someone to do some math for me. 6 times negative 12. Oh, so fast. Negative 72. Math is not about speed, though. Arrow, what is the right-hand side? 0. All right, so we have 8 A prime minus 72 is equal to 0. Obviously, we're going to add 72 to both sides and then divide by 8, and you guys can hopefully do that in your heads. A prime is equal to, is it positive or negative 9? It is indeed a positive 9. And what are our units? Feet per minute. Because I'm talking about A prime, so I'm talking about a rate. All of our rates here are in feet per minute, so this is going to be feet per minute. All right. We went through that problem really fast, and I'm uncomfortable with how fast we went through that because I feel like we might have left some people behind that didn't speak up. This is your chance to digest, to ask questions. Let me ask a question. Is this sliding to the left or to the right?
Right.
Why is it sliding to the right?
It's gonna,
Oh, it's just like the way that it falls down physically?
yeah.
Okay.
The number is positive.
Ah, that's another way to think about it. If we define up as positive, that means right is positive and left is negative. We're thinking about like the coordinate plane, right? That's another way of thinking about it. Yeah, anything else? Any other questions? We're okay with this question? I would consider falling ladder problems to be pretty straightforward. There's not a tricky way that I can ask it aside from making square roots and things like that. Yeah, square roots are going to happen maybe if I did example 2 badly. We'll try it out. All right, so if there's no questions, let's talk about example number 2. Someone aside from Claire, please read.
Rayleigh and Alex are in motorboats located at the center of the lake. Rayleigh begins traveling south at a speed of 21 miles per hour. At the same time, Alex takes off heading east at a speed of 20 miles per hour. What rate are they separating after 2 hours?
There it is. So, what is our first step? Always with triangular related rates.
Triangles. Good
Do what with triangle? Picture. There it is. Draw the triangle. So I'm going to start. I know that I'm going to be going left, or I'm going to go right because right is east, and I'm going to go down because down is south. So leave some room for south and east. So I'm going to start my triangle right here. So I'm going to say, yeah, I'm going to start right here. Somehow Alex and Riley are on top of each other, which is mathematically possible, but physically impossible. It looks like Riley's going to go south. So here we go. Riley, you're going that way. And you're going 21 miles per hour. Do you guys want to make this positive 21 or negative? Well, this rate. Yeah, it doesn't really matter for the signs. We just need to know what it means at the very end. Obviously, our end answer should be a positive because they're still separating. You want to make it a positive 21?
Mm-hmm.
What letter do we want to use? B. All right, so we're saying B is B or B prime is 21. B prime is equal to 21. Okay. And then we also know that Alex is taking off heading east, so going right at 20 miles per hour. So I'm going to guess you're going to use A here. Is this A or A prime, Geostego? A prime is equal to 20. All right. All of our units are miles per hours. It seems like we have very little information. Like, look at this. We have 2 variables. In our equation, we need to at least have 5 of the 6 variables in order to solve this thing. We're missing a ton. How are we going to find a lot of these missing variables?
You can find C prime by like adding those two, right?
Unfortunately, you cannot. The only way they can find C prime is using this equation from the derivative of Pythagorean theorem. And in order to use that equation, I need to get all the other unknowns. In fact, that's what it's asking for. At what rate are they separating? So if I come and draw that right triangle finally by drawing the hypotenuse, this C prime, that's the thing that they're looking for. How fast is this distance between them? How fast are they separating if you're just looking at the 2 boats? What is that C prime?
Can I just do like B prime square root of 2?
You can't, unfortunately.
That too is important. You know, you see it.
Yep. So we haven't used the fact that there's a 2. And Arrow, you have it correct. If they give you information, you need to use it. That's how the AP test works. So how are we going to use 2 hours? Multiplication for rates. Yep. So again, this crosses over to physics quite a bit. This is like the easy kindergarten physics. If I go 60 miles per hour and I drive for 1 hour, how many miles have I traveled? 60. You multiply them together. All right. Anyway.
So let's do that.
So you multiply B prime.
Let's come out here to the left. Let's talk about Riley. Riley's traveling 21 miles for every 1 hour. 21 miles per hour. If I were to multiply that by 2 hours for every 1 blank, just 2 hours, notice that the units here cancel out. Hours and hours cancel out, and 21 times 2, shout it out, is
42.
42. And what are our units? What is the last unit that's remaining?
Hours.
Hours were canceled off, so miles. And that's how multiplying works, right? So you multiply 21 by 2, and I get 42 miles, which is really nice, right? So that means what is 42?
That's going to be B.
B is 42. Nice. Okay, well, let's go ahead. Oh my gosh, did my units come out badly again? I think they might have. I'm scared. Wait. I think it might be okay. I'm seeing ahead a few more steps. We're okay. Okay. How about, let's talk about Alex. Alex is heading at a speed of 20 miles per hour. So 20 miles for every 1 hour. That's not how you write an hour, Mr. Sindel. And again, he's going for, he or she, I don't know, 2 hours. And again, hours and hours are going to cancel out. 2 times 20 is 40
Miles.
40 miles, because hours were canceled out on the top and bottom. Which means, what letter is 40? 40 is A. Okay.
Now you can use Pythagorean theorem to get C and then get C.
Let's do it, yeah. So Pythagorean theorem. So we're going to do 40 squared plus 42 squared is equal to C squared. Oh God, Mr. Sindel, what have you done to us? Well, 40 squared isn't that hard, right? It's just 1600.
Plus 1,764.
Well, that's
Thanks,
the end
Bill.
of everything.
But you did that really fast.
Oh, I did it before.
Oh, okay. I'm like,
Yeah, that's how I
it
did
took
it.
me at least like 10 seconds to do that in my head. Is equal to C squared, and then I need to actually add those together.
Which is 3,364.
3,364.
And the square root of that is who knows?
Yeah.
Let's take an educated guess.
It's gonna be somewhere between I don't know and I don't know.
Yeah.
So, this is almost a 45. Don't use computer. Let's use some logic, just some brief logic. I want to show you how I think at least. Maybe you guys can emulate me. I don't know. This is almost a 45, 45, 90 triangle, yeah?
Yeah.
Which means that this should be basically 20 square root of 2.
But it's not exactly.
But it's close to 20 square root of 2, right?
But it doesn't say
So what is square root of 2? You guys should have an approximation of square root of 2 and square root of 3. That's all I'm asking for you guys, for like the whole AP calculus. What is the square root of 2?
It's like 1.5 something.
Oh, you need to at least get the first decimal point.
1.2.
1.4.
I was close.
You were close. So if I do 1.4 times 20, 1.4 times 20, I get about what?
Good question. 25.
2.8.
28.
Oh,
That's the number.
28.
How did I do that?
You just
Well,
get
what's
got rid of the.
why?
1.4 times 2 is 2.8, and then adding the 0 moves the decimal place. So this should be about 28.
Just figure it out.
What is 28 squared? You can do 28 a different way too. 28, 28. This is 20 plus 8, 20 plus 8. 28 times 20 is 400. 20 times 8 is 160, 160, and 8 times 8 is 64. Add them all together, you get, that's 320, 384, 7,
That's not right.
oh, 4,000, sorry. Missed a 0 there.
Isn't it
It is 400. What happened?
It's only 800.
How about we use computers?
Okay, we're gonna have to use computers. 784. How are we so far? Oh, because we have to double it. It should have been 40 times because we were using 42 and 40. So we should have been using a special right triangle with 40. Well, you just have to double this. If you double it, then I'm going to be doing essentially 41 times 41. Anyway, let's just skip kind of ahead. Hey, it actually did come out nice.
It's 58.
Yeah, 58.
If we come across these on the no calculator, or is there a no calculator section of AP Calc?
Yeah.
Yes, half of it is no calculator.
Which is a lot.
If we come across something like this, how would we just hide?
They will use smaller numbers. I used bigger numbers for the example, so I didn't take away from the other ones. C is equal to 58, so we can come down here and say C is equal to 58, and now we have everything that we need. And by the way, last time on example 2, C was like the square root of like 2,000 something. It didn't come out to a nice number. So the fact that it came out to 58 means this problem is working. All right. From there, fill into the equation. Again, our equation is AA prime BB plus BB prime is equal to CC prime. So we have 20 times 40.
42 times 21 equals to 58. C prime.
There it is. And I'm just going to kind of skip to the answer again because these are really big numbers.
It's 800 plus 882.
Plus 42 times 21. 1,682 on the left. 1,682 is equal to 58 C prime. And 1,682 divided by 58 is 29. 29 is equal to C prime. And what are our units here?
Miles per hour.
29 mph. Which is kind of cool, right? That's a real problem. Like if you head out east at 20 miles per hour, someone else heads out south at 21 miles per hour. After 2 hours, your distance between you two is changing at a rate of 29 miles per hour.
That's a huge lake.
This is a good point, Claire.
That is a
It's
big
like-
lake. Maybe next year I can change this problem to smaller numbers.
You could
I can make it a 3, 4, 5
ocean
triangle.
instead of lake.
I like the 5, 12, 13 triangle because most people forget about that one. I'll think about it. Anyway, that was example 2. We're done.
That's it.
Preguntas?
It doesn't.
Yeah, general procedure, find 5 variables and solve for the 6.